Okay, now we have a 7-foot tall person is walking towards, should say, an 18-foot tall lamppost at a rate of 5 feet per second. Assume the scenario can be modeled with right triangles. That's important because right triangles form ratios. At what rate is the length of the person's shadow changing when the person is 20 feet from the lamppost? So unless you draw the diagram with this, I have no idea how you would figure that out. So, and usually that's the most difficult part. And when I was learning this stuff, that definitely was. Okay, so here's our lamppost, and look at, I even have it, putting off some light. And now we have this 7-foot tall person walking. Is this towards? So because it's walking towards the lamppost, this distance right here is getting smaller. So that this rate is actually negative. The rate that this person is walking from here to the lamppost, that distance is getting smaller, so that will be a negative rate. At a rate of 5 feet per second, you're closing in on the lamppost, that's a negative rate. And then this person, as you're walking, we're producing a shadow, and that shadow will have a rate, and that's what we're trying to find. But what we know, look at, we have this triangle right here. Let me put that in a different color. We have this triangle that sits inside, and what we've learned, if they're both right angles, well, if they're both right angles, then they form a proportional relationship. So look at what we know. We know that this y is proportional to the 7 feet. I believe that's what I put right there. Yep. So the base is to the height. So we did the base is to the height. So base 1, height 1. And then we're going to do the second base is to the second height. Well, the second height we know is 18. Well, what is the first base? The first base from here to here is x, and from 7 foot to the end is y. Okay, so the second base is x plus y. Well, we know with proportional reasoning, you start doing this in 6th grade, maybe not with x's and y's, but proportional reasoning is, if not before, certainly. So I'm going to multiply this side by 18. That cancels, but then I also must multiply this side. This side, I'm going to multiply this side by 7. I know you learned cross multiplication, but I want you to know why legally it works. It's because invisibly you're multiplying this side by 7. Well, this is going to become a distributive property. So now we have 18y is equal to 7x plus 7y. So let's get the y's to the same side. So now what we have is 11y is equal to 7x. And remember, every time you have a related rate, you use implicit differentiation. But now you actually have two rates. You have dx dt, and you're finding dy dt. So you actually have to use implicit on both of these. All right. And you do the other times, it's just the other part is kind of invisible. So, oops, most of the time professors don't have you write that. Okay, so when we take the derivative of 11y implicitly, it becomes 11 dy dt. We take the derivative of 7x, it becomes 7 dx dt. Well, it's the dy dt that we're looking for, so we're going to divide both sides by 11. And then we can substitute what we know. So dy dt is equal to 7 over 11 times dx dt. Well, dx dt, okay, I got a call, so I'm not quite sure where I left off, but since this right here, I've already removed that, the box covering it. So dy dt, you just multiply that out, and you get negative 35/11 feet per second. So related rates, implicit differentiation, drawing the diagram, and when the distance is getting smaller, it's a negative rate. If this person was walking away from the lamppost going that direction, the distance would be getting bigger. That would have been uh, a positive 5 feet per second. All right, that's it for this one.